Okay, this is the first unit of Chapter 8. Chapter 8 is Integration and Context, or Applications of Integration. We're starting out with 8.3, which is Rate In and Rate Out functions. We're going to do one example to kind of demonstrate the whole concept of Rate In and Rate Out functions. So the scenario says there's a grocery store that opens up. It has 50 pounds of bananas. That 50 is what we call our initial amount. Customers remove the bananas on the display table modeled by this function. So this function models the amount of bananas that are removed from the table. And again, we started out with 50, where f of t is measured in pounds per hour, and t is the number of hours since the store opened. So this is from 0 to 12 hours. So right when it opened to 12 hours after it opened. This is a key part. So after the store has been open for 3 hours, the employees add bananas to the display table modeled by this function, where G is measured in pounds per hour and T is the number of hours. So again, that 3 represents 3 hours after the store opened to 12 hours after the store opened. And again, these are in the calculator in Y1 and Y2. Just to show, if you go to your Y equals, I have my two functions as Y1, that's the rate in, and Y2 is the rate out. So whenever you encounter these types of problems, you need to be able to identify how much is going in and how much is going out, and there's always a starting value. So in our case, our starting value was 50 pounds of bananas, and we call the total function as A of t. So that is the amount of bananas in the store at any one time. Now, we use Y1 or Y2, sorry. In this case, it is G of t. Again, Y2 is what's in the calculator. But this function models the rate in. Our units are in pounds per hour. And then our rate out function is measured by f of t. And in our calculator, that is Y1. And that is, again, the units are in pounds per hour. So if we write an equation for the amount of bananas on the table at any one time, so if we were to write an equation that models this situation, you're always going to start with your initial amount, which in our case is 50. And then you have your rate in function minus your rate out function. And we do have to take the area from 0 to our time that we want. So again, this is the amount coming in, subtract the amount going out. And the reason we do an integral is because an integral, if you recall, is the summation of a bunch of values. So we're adding up all of the bananas that are put on and subtracting all the bananas that are put out. So again, this is kind of our formula that we're going to use. So how many pounds of bananas are removed from the display table the first 2 hours after the store opens? So this question is going to involve the function f of t. So if I were to try to find this, basically I want to find the integral from 0 to 2 of f of t dt. And again, because that's from when it opens to 2 hours after it opens, the function t, it represents the amount of bananas that are removed. And we're just going to do this in our calculator. We do not want to do this integral by hand. So let's go to our calculator. And again, this value in our calculator is going to be Y1. So to find this, we need to do the integration. So hit your math symbol and then go down to number 9, which is function integration from 0 to 2. And again, you can type in the function here, but since we already have it typed in as Y1, we're going to go to variables, go to Y variables, functions number 1, type in y1 and then hit enter. And so that is our answer, which means it's 20.0511 pounds of bananas removed. Part B, it says find the derivative at 7 using correct units. Explain the meaning of the derivative of 7 in context of the problem. And again, please don't compute derivatives by hand. Let's use the function. So the units for the functions is pounds per hour. And then if I take the derivative, again, this is in pounds per hour, and this is hours. So when you do the slope, it's going to be pounds per hour over hours. Or you can say it as pounds per hour squared. So again, our function was in pounds per hour. Our time is in hours. I'm sorry, this is backwards. I goofed up. And again, remember, the slope is rise over run. The derivative, this is in pounds per hour. This is in hours. So it's pounds per hour, or pounds per hour squared. Now, we just need to calculate the derivative at 7. And again, we're using f. In this case, is our y1. So let's go back to our calculator. And we want to find the derivative at 7. So again, go back to math. Number 8 right there is derivative. Our function in our calculator was y1. And we want that at 7, and that is our derivative, negative 8.1195. So what's f of t in context? That is the rate the bananas are removed. We're going to say it is decreasing because our value is negative at a rate of, and that was 8.1195 pounds per hour squared. And we need the time at t equals 7 hours. So again, that's interpreting the derivative in context. You have your f of x, or whatever the function is in context, increasing or decreasing, depending on if it's positive or negative. Make sure you include the units and the number. And again, since this is decreasing, we do not write this as negative. The decreasing means that this is negative. So part C, is the number of pounds of bananas in the display increasing or decreasing at time equals 5? Give a reason for your answer. So what we're going to do, we want to know if the bananas are filling up faster or if the bananas are leaving faster. So what we're going to do is we're going to find the rate at 5, which the bananas are coming in, or going out, sorry. And then G of 5 is the amount that the bananas are coming in. So again, your rate in is G, and your rate out is F. This is how much bananas are coming in at time equals 5. This is how many bananas are going out at time equals 5 in pounds per hour. So again, we're going to go back to our calculator. We're just going to plug in 5 for both the in and out function. So the way to do this is we don't want to type in 5 to these. Since we already have them typed into our calculator, we're just going to go to variables. Go to y1. And we just want to type in 5. And so that is 13.7959. And then we're going to do the same thing. Go to variable. Go to y-axis. Go here. Go to number 2. My thing is glitching. And then we have 11.53 pounds. So let's write those answers in. So again, remember what F is. F was what went out, G is what went in. So the amount of bananas going on the table are 11.5 pounds per hour. The rate of bananas going out of the table is 13. So there is more going out. So we are decreasing with the amount of bananas on the table. Again, because there's 11 pounds going in at time equals 5, but there's 13 pounds going out. So the number of bananas on the table is decreasing. And you just have to explain that. And the explanation is the rate at which the bananas are being removed is greater than the rate that they're being added to the table. Okay, so part D. How many total pounds of bananas are in the display table at time equals 8? So part D. How many total bananas are in the display table at time equals 8? So what we need to do is we need to have our starting amount of bananas, and then we need to calculate how many bananas are added from time equals 0 up to time equals 8, and then subtract that from the amount of bananas that were taken away from time equals 0 to 8. So this function we call a of t. Our initial amount was 50. Now, this is the rate n function. So if you come back up here to look, here's our rate n function. But remember, this is only from 3 to 12. Again, because they only start 3 hours after the store opens. So we want the integral of g to t from 3 to 8. Okay, so what we have now is our 50 pounds of bananas plus what was added from 3 hours to 8 hours. And then we need to subtract the rate out function, which was f of t. And this started from the very beginning, from 0 to 8, because it was right when the store opened to time equals 8. Now this, we're going to do this in our calculator. We're not going to do this by hand. And if you recall, g of t was our y2 in our calculator, and f of t was our y1. So just so we have a reminder when we go to our calculator. So coming here, we have 50 plus, now we want to do the integral, which was from 3 to 8. And again, remember, this was our y2, so go to variables, over to y variable, and then go to y2. And then we're going to subtract our rate out function, and that was from 0 to 8. And in our calculator, this was, go over to y variables, and that was our y1. Uh-oh, what happened? And we get an invalid answer. So I think we're going to have to calculate each part by itself. So let's redo this. Let's go math, integral, 3 to 8, and this is y2. Get an answer. So this first part is 58.96, and then we're going to cheat this. We're just going to go back, change that to a y1, make that a 0. Yeah, so you cannot, I guess you cannot put the integral in as 1, but we have each part calculated, so it's going to be 50 plus this 58 minus the 85. 50 plus, there we go, minus 86. And so that's what we get. We had to do each of them separately. So we get 23.34739. And again, that's pounds of bananas.